All right, so we practiced the transformations and we practiced graphing transformed functions. Now we're going to talk about the order in which the transformations happen. Didn't matter that much when you had an actual function. We just made a table of values. What do I get when I plug in 1? What do I get when I plug in 2? But what we're going to do today is transform functions that don't have an equation associated with them. So you can't just plug in any number and make a table. You have to actually transform each point one by one. So I'm going to illustrate this for you before I actually tell you what the order is. Looking at this first example here, there are 2 transformations. What are they? Can someone give me one of them? What's one thing that happened? Up 4, and then what else? Good, reflective or X, because the negative is outside. So we're going to do one of those in one order and one of them in the other, so you can kind of compare and contrast. All right, so first, this is the order you guys set them to me in. So we'll do up 4, and then reflect X axis. And you're going to kind of have to use your imagination because I don't have a parabola that I can hold and move around. So you're going to kind of have to, imagine this with me. But it would start out here. So, centered at the origin. You following me there? Okay, we have to turn on your imagination. Then you would go up 4. So it would be right here. And then you would take that and reflect it down to here. So it would start out in the center, you would move it up 4, so you'd have a parabola kind of up here, and then you would take it and reflect it down. So it would end up looking something like this. If you did it in that order, you took the parabola, you moved it up 4, and then you flipped it. So it wasn't the center, it went up 4, and then it's upside down. I know I look goofy doing this, but I don't care. If it helps you understand visually what's happening, then that's good. So let's say we did that in the other order. Let's do the reflection first. So we're going to do reflect X axis and then move it up 4. So again, I'm just going to kind of try to mine this out, point to the paper, just use your imagination. You have this parabola here in the center. First, we're going to flip it upside down. So it would be going this way. And then we're going to move it up 4. So you would have something like here. So again, your parabola would be here in the center. You're going to flip it upside down and then move it up. So again, one of them is wrong. You can't be like, oh, well, it doesn't matter. It does. One of them's correct and one of them's incorrect. Let's say this is choice A and this is choice B. Who thinks it's choice A? Who thinks it is choice B? I think almost everybody voted. Good. It is choice B. You're going to have to do the reflection before you shift it. So on your notes, make sure you state somewhere that this is wrong. It is not this one. Right, that is the incorrect one. You have to do the shifts last, because if you shift and then reflect or then stretch or shrink, you're reflecting a moved graph. So you have to do those shifts last. So here's the order that they're going to go in. We're going to do all of the inside stuff first. So let's talk about all of those transformations. We're going to do all the things that happen inside the function first. And the first thing you would want to do is reflect. If you have a negative inside, that's going to reflect over the y-axis. So that's your first thing, is do the reflection. Then you would want to stretch or shrink it. So if it's inside, that would be horizontal. So you would do a horizontal stretch or shrink. And then last, you would do the shift. If the change is inside the function, that would be left or right. So that's all the stuff that's inside. You do the reflection first, reflect Y, horizontal stretch or shrink, then move left or right. All those things affect the X values. Remember, inside affects the X value. And then you're going to do all the outside stuff, and it's going to go in the same order. So then you're going to move to the outside of the function. The reflection would be first. So you're going to reflect the x-axis. If the negative's outside, that reflects x-axis. So a vertical reflection. And then your vertical stretch or shrink. And then a vertical shift, which would be up or down. So it goes in the same order. It's the reflection, the dilation, the stretch or shrink, and then the shift. We're going to do all the inside stuff, then all the outside stuff. If you have something outside of the function, that's going to affect your y value. And that is important, whether it affects x or y, because we're going to transform functions that, again, don't have an equation that go with them. You're going to have to just do it point by point. And if you want to number these, and sometimes this helps, like if you want to say reflect y-axis, that's first, this is second, this is third, this is fourth, fifth, sixth. That's the order that we're going to put them in. It does matter, especially if you don't have an equation to look at. So we're going to practice these. We've been doing this the last couple of classes. The only difference is now the order does make a difference. We're going to make sure that we get this in the right order. If you want to highlight, you can. If not, that's cool. I'm going to highlight what's inside the function so we can tell what's inside and what's outside. So this is the part that's inside the function. It's a quadratic. So everything inside that's being squared is inside the function. So we're going to start there. We're going to start with the part that I highlighted. So what is the inside transformation? Good, right 6. And that's the only thing that was inside. So you can't get that out of order because it's the only thing that's there. And again, I'm going to give you the number of lines for how many answers there should be. So don't fill them all and don't add any extra ones. That's how many answers there should be. Now we're going to go outside. Outside of the function, we have the 1/3 and we have the -8. So which one's going to happen first? Good, the 1/3. And how would we write that? Vertical, because it's outside. Good, shrink by 1/3. And then lastly, the -8 moves it down 8. So now you just kind of need to start on the inside, work your way out kind of thing. And we're just going to practice that a couple more times. Now, for these next 3, I made ones that we have to factor because that's a skill that you do need. And it's not like really intense factoring. We're just going to do GCF. Do you remember greatest common factor where you have something in common and you factor that out? Okay, look inside that function. Do you see the 2x - 6? What could you factor out of that? 2. Factoring is undistributing. You're going to undistribute the 2. And we're just going to have to decide what's going to go in those parentheses. So if you divide out a 2, like undistribute a 2, what would be left? Yeah, good, x - 3. And you can always check your work. Like, hey, if I were to distribute that 2 back through there, I would get 2x - 6. Like you would get what you started with. You have to do that so you can see what the shift left and right is. If you don't factor it, then you're not going to get that. So this is absolute value. This is what's inside the function. We're going to start with that. Bless you. And here's where this does get people, and it's a little tricky because it's not order of operations. It's not PEMDAS. We're not starting inside the parentheses. You kind of have to let that go because it's not order of operations. The shifts come last for this reason. All right. You have to shift after you've reflected and stretched or shrunk it. So when you look inside, this 2 is actually going to be the first thing. And remember, when it's inside, it's kind of backwards. So it'll be a horizontal something or other since it's inside. And what will that 2 be? It'll be a horizontal what? It shrink by 1/2. You have to reciprocate it. All right, then the other thing that's inside is the x - 3. So what's that going to do? Good, right through. So that's the inside stuff. Now we're going to move to the outside stuff. We have a negative and we have a +1. Which one is going to happen first? Good. The negative, which would be a reflect over what? Good. X-axis. I think somebody said it. I just couldn't hear you back there. Reflect x-axis, and then the +1 is up 1. All right, cool. Hanging in there. We're just going to practice a few more, right? Now this one, we have to factor a negative out of this negative x plus 1. Just like we had to factor this 2 out of here. If there's something in front of the x, then you have to factor that out. So we're going to factor that negative out of there. You're undistributing a -1. And some people like to put the 1 in there. I just put a negative sign, but you could put a -1 there. We're going to factor out a negative, which means everything's just going to change its sign, just opposite day, basically. So what would go in those parentheses that I left? Yeah, good, x minus 1. And again, the way you can check your work is if you were to distribute this negative through there, you would get what you started with. But you have to factor it, or you can't tell what your shifts left and right are. So it has to be factored. So this is square root, and everything inside the square root is inside the function. And I know that this is hard because it goes against your instincts. It's not order of operations. So it's not PEMDAS. We're not starting with the parentheses. What's the first thing going to be? Yeah, good. Reflect y-axis. Nice. And then the x minus 1 is going to move us right 1. And that's all the inside stuff. Now we're going to do all the outside stuff. So what would be the next thing? Yep, good, the 5. So vertical stretch by 5. And then lastly, up 7. People always want to know, like, how hard can this get? This is about as hard as I can make it. This is about as messed up as I could, make one of these. This is a lot of transformations here. All right, and there's a fraction, which I know throws everybody off, right off the bat. We are going to have to factor a 1/2 out of there. We're undistributing a 1/2, right? Dividing by a 1/2 is the same thing as multiplying by 2. And I will say that again. Dividing by a 1/2 is the same thing as multiplying by 2. Dividing by a 1/3 is the same as multiplying by 3. You're multiplying by the reciprocal, right? So if we factor out a 1/2, we would be left with x plus what? Does anyone want to give it a guess? Good, 4. 2 times 2 is 4. The other way you can check that, again, is if you distribute this 1/2 back through there, you will get 1/2 x plus 2. You'll get what you started with. All right, so it's a cubic function. Everything inside the cubed is what's inside. There's 5 of them. What have you got for me? What's going to be first? Yep, good, nice. Got to flip it over. Horizontal stretch by 2. All right, and then the x plus 4 will be left 4. That's all the inside stuff. Now outside. There's a -4 out front. The negative and the 4 are separate. Those are 2 different transformations. The negative does one thing and the 4 does something else. And we do the reflections first. So the negative is going to be what? Yep, good, reflect x. Because people think of the -4 as like a single number, and I get that -4 is a number, but the negative does the reflection, and then the 4 is vertical stretch by 4. So they do 2 different transformations. And then the -5 is down 5. And that is about as difficult as I can make it. So if you felt like you got through that, okay, it's not really going to get any harder than that. All right, so when we flip this over, we're going to be transforming this graph right here. And so like I was saying before, you can't fall back on what if I plug in 1, what if I plug in 2? There's no equation to plug into. You have to actually just manipulate the points one by one. And I'm sorry this one didn't get bolded right here if you want to bold that point. But there's these 5 points that we're going to manipulate one by one. And so what we want to do is write those points in a table. These are like the original points. And then when we go to do the transformations, we can look at the original table. All right, so the original points that we have, we've got -5, 0. We've got -2, 3. We've got 1, 0. And let me see, 4, 4. And 5, -2. So that's just writing out what they are originally so that we can look back at that. And again, I'm going to highlight what's inside the function. This is how we're transforming it. So the f of 2x, that's the inside part. Now, this is optional if you want to write out in words the transformations. I'm going to do that because I'm your teacher and I'm teaching you and I'm trying to show you every last little thing. You know, it's not required, you don't have to write it, but I'm going to write it out. That 2 is inside, so it's going to be a horizontal something or other. And it's kind of backwards, so it would be a horizontal what? Good, shrink by 1/2, perfect. And so when I make my new XY table, I need to do 1/2 of my X values. You have to multiply all your X values by 1/2. And if you look back at your notes from 2 classes ago, that little cheat sheet where we kind of did all the transformations in one place, you have it written on there. I wrote it out, multiply X values by, 1/C. Remember we did that? It's on there. That's the stuff that's inside, that one thing. Now we're going to go outside. You have to do the reflection first. So this would be reflect x-axis. Again, I'm just being super thorough by writing that out. That's what's going to happen. And then we're going to go up 3. So anything outside is going to affect the y value. And so we would want to opposite the y value and then add 3 to it. So that's our new rule. We're going to have 1/2 of all of our x values. And then for the y's, we're going to opposite them. So if they're positive, make them negative. If they're negative, make them positive. And then add 3 to that. So let's do all the x values first. Here is your column of x values. All you have to do is 1/2 of those. So 1/2 of -5 be -2.5 or -5 halves, mean the same thing. 1/2 of -2 would be -1. 1/2 of 1 is 1/2. 1/2 of 4 is 2. 1/2 of 5 is 2.5. And then for all our y values, again, we're going to opposite them and then add 3. All right, now the first one's 0, which is actually kind of nice because you can't opposite a 0. There's just 0. And then you would add 3. So 3. Now this one, you're going to opposite it. So it would be -3. And then you would add 3. So 0. And then this one is the same as the first one. These two are the same. And then 4, you're going to make it opposite. So -4 plus 3 would be -1. And then this last one, make it opposite. So it would be a +2 plus 3 would be 5. And then all you have to do is plot those points and connect them. That's it. Once you have to do it point by point because there's not an actual equation to plug into. But now that we have these, we're going to plot them and just connect the dots, right? -2.5, 3 would be right there. -1, 0. And then 1/2, 3. That's your semicircle. we kind of have like a semicircle and then sort of like a triangle, if you will. I'm going to call them a semicircle and a triangle just for the sake of being able to call them something. All right, and then we've got 2, -1, and 2.5, 5. I am always going to give you a grid that it will fit on. So if your graph goes off the grid, you had a whoops somewhere, because I'm going to give you a grid that it should fit on. And then what you can do to kind of like check your work, I know a lot of people are like, well, how do I know if that's right or not? There's not like a place to plug it back in. I get that. It's sort of like your safety net went away. If you write these out, you can sort of just check, did those things happen? So does it look like we took this graph and horizontally shrunk it? Like, does it look like we compressed it inwards? Like we smushed it? Yeah. Did we flip it upside down? Yeah. And did we move it up 3? Yeah, it went up 3. So you, without a doubt. So that's how you can kind of check is like, did these things happen? All right, this one needs to be factored. We're going to factor out the 1/2. Again, dividing by 1/2 means you're multiplying by 2. We're taking the half out of both of those. And so what would be left in those parentheses? This one, you can kind of just think about taking out the half. Like we're factoring out the half. So like that part's gone. So it would just be x minus 3. Like we removed the part that was the fraction. Now I'm going to highlight the whole thing because all of that is inside, which is kind of nice because if there are no changes outside, we don't have to adjust any of the y values. They're all just going to stay the same. We didn't do anything to the y values. This is all just going to change the x value. So your y values are just going to stay y, like those are just going to stay. All right, but inside, we have a horizontal what? Remember, it's kind of good. Horizontal stretch by 2. And if you don't want to write that out, I'm not going to force you. I'm just writing it out to be thorough, and so we can kind of like check it at the end. Like, did it look like that happen? Horizontal stretch by 2, and then right 3. So you want to double your x values. And then to move to the right 3, you're going to add 3. So we're going to double them and then add 3. All those ones inside are kind of backwards to your instinct, the opposite of what you expect. But we want to double it. We're going to stretch it this way and then scoot it over 3. All right, so we're looking right here. These are our original x values. We are going to double them and then add 3. All right, so -5, double that, you would have -10. Add 3, you have -7. All right, I'm going to ask you guys the next one. -2, double that. -4, add 3, -1. There we go. All right, 1, double that. 2, and then add 3, 5. Good. And then 4, double that would be 8, plus 3, be 11. And then 5, double that, you get 10, plus 3 would be 13. And so again, what was nice about this one is the only transformations were inside. All these y values are just going to stay the same. So you can just copy those over. We didn't have any vertical transformations. So they all just stay the same. We like no work, right? Really likes no work. All right, so you're going to plot those and then play connect the dots. All right, -7, 0, -1, 3, 5, 0. That's your semicircle. I'm not grading your art skills, just make an attempt. And then 11, 4, and 13, -2. So again, the way you can kind of check your work is, did we do these things? Did we stretch it out this way? Yes. I scaled the axis for you. So, it doesn't look much bigger, but that's because I made it so it fit. So we stretched it by 2 and we moved it to the right 3. It went right a little bit. All right, this one is factored for you, which is nice. The F of all that stuff is the stuff that's inside. So I'm going to write them out in words, again, just so we can be thorough and check our work. First thing you would want to do inside is what? The negative or the +4? Which are we going to deal with first? The negative. That is a reflection over the y-axis. And then the +4 is left 4. Now, those are the things that affect x. Inside means x. So we want to do a reflection. That means we're going to opposite the x. If it's positive, make it negative. If it's negative, make it positive. Left 4 means you have to subtract 4. We're going to opposite it and then -4. And then outside, we have a 2. What is that going to do? Let me write it out in words first. There we go. Nice, thank you. Vertical stretch by 2. Those ones are kind of straightforward. They make sense. The inside ones that give you a hassle. But the outside ones just make sense. So what am I going to put right here? What am I going to do to all my y values? Yeah, 2y. You're just going to double them. All right, so the x's, we're going to opposite them and then subtract 4. So this first one, -5. If you opposite that, it's 5. 5 minus 4. All right, -2. Change that. That will be +2. -4 would be -2. So that almost looks like that didn't change, just coincidentally ended up where it started. All right, 1, you're going to make it negative. So -1 minus 4 would be -5. 4, you would make it negative. -4 minus 4 would be -8. And then this one would become -5 minus 4 would be -9. And the y values are a little bit easier. All you have to do is double them. 0 times anything is going to be 0. So both of those are going to say 0. 3 times 2 would be 6. 4 times 2 is 8. -2 times 2 is -4. Again, you're going to plot them, play connect the dots. See, as we get to this point in the lesson where no one's really looking at me anymore, you all just went and did it, right? Because we do one example and everyone's like, I don't quite get it. And then we do the second one and everyone's like, okay. And then by the third one, everyone's like, leaving. And then to check your work, you can just kind of go down the list and say, all right, did we do these things? Reflect y-axis. That means flipped horizontally, like a pancake. So does it look like this? Here, let me zoom out so you can see them both at the same time. Does it look like we took this and flipped it side to side? Yes, the triangle and semicircle are on opposite sides. Left 4, that's a little bit harder to see, but yeah, this way. We went left 4, and then vertical stretch by 2, does it look taller? Yes. No question.